Hey guys, my name is Tatiana Browne, and I'm going to be showing you how to name chemical compounds, ionic and covalent, and how to draw a Lewis structure, and how to sketch on a 3D structure. So, with ionic compounds, they're going to be consist of metals and non-metals. And here are a few examples, and then it's also important that we learn how to name positive ions, which here are other examples. When there are positive ions that have more than one oxidation state, they're gonna turn into Roman numeral. So for example, Fe2 plus, and that's supposed to be my Roman numeral with the name. And then we also have positive platonic ions, have common name ending in suffix, which is this. And then this is an example. And then if they have negative ions, they're going to end in IDE, which is an example. Naming, and then to go on for covalent compounds, naming covalent compounds oxidation states play a key role, which they consist of non-metals, both is non-metals. So if you see a metal and a non-metal, and I mean you can tell on your periodic table whether they're non-metal or metal. If you see a metal and a non-metal, they're going to be ionic. And then if you see a non-metal and a non-metal, they're consist of, it's a covalent. And then these are a few examples. And the amount of atoms of elements indicated by Greek prefixes. So which is like one is mono, and then 2 is di, 3 is tri, and then 4 is tetra. And then pretty much. And to go on to how to find the Lewis structure. So first you'll find the total valence electrons, and if you just look on your periodic table, you'll be able to see. And here's an example, H2O. So since it has two, it has two hydrogen. So you'll do the 1 valence electrons for hydrogen, because hydrogen is 1 valence electrons times the 2 plus 6. Don't mind that. So it equals 8. And with the Lewis structure, the valence, like when you're finished with the whole product, you should have 8 valence electrons on the finished product. Find the number of valence electrons needed to make the atom happy. And then you're going to put least electronegative atom in center. So F is the most electronegative. So what comes before that is the one that's going to be in the center, and then the other ones is going to be in the outer. The valence electrons are the outer shells of the letters. So here's an example. Cn negative, it's negative. So when it's negative, you add a 1. So 4 plus 5 plus 1 is 10. You're going to put 2 electrons between atoms to form a chemical bond. It shows that it's chemically bond. So here for an example, you're putting 2, and then complete, I'm not going to lie, I don't know how to say that, on the outside, octex. And then basically, it's going to look like this. And central atoms do not have an oxygen move electrons from outer atoms to form double, triple bonds. So basically what that's saying, if they don't have no chemical, like if it doesn't show that it's chemically bond, you'll move